Welcome to another episode of TrueNAS Tech Talk. On today's episode, we have Fangtooth RC1 launching next week. We're going to dig deeper into the containers, LXC, and VM discussion from last week, and we'll answer a couple of viewer questions that came in this week. So, hey, welcome back. It's great to have you on the podcast again, Chris.
Happy to be here.
Yeah,
we're lucky both to be here. We've been traveling this week.
Chris and I were both traveling back and forth. We got to see each other in person, but unfortunately, we didn't have time to record the podcast where we were. We had to come back to our respective locations this Friday and bring the podcast to you from our usual location.
No, we'll plan it better next time so we can do some live in-person stuff, and that'll be fun. But
Absolutely.
Anyway, we're glad to be back and a little over the jet lag now. We're in good shape.
Yeah. Okay, so first off, we got RC1 launching next week, just in a couple days, actually. We're targeting Tuesday the 11th. Is that right?
Yeah, that's the plan. So we got the last internal builds happening as we record right now, so that's great. Barring no major problems or issues, we expect this to go out Tuesday as planned. It's looking pretty good. A lot of bug fixes were merged. So RC1 is what we consider now feature complete, and pretty much this is the release candidate. We're getting ready for the .0 next month. So we had a pretty decent showing of upgraders, and a lot of feedback came in from Beta 1. Super appreciate it. Keep that coming. A lot of tweaks went in again to try and improve the new instances and Incus stuff and the experimental feature. That's still getting a lot of love. So you'll see a bunch of those fixes land in the RC1. Speaking of that, I actually ran into something weird. I was also kicking the tires on it heavily this last week. I had a little bit of free time. I noticed inside the Incus UEFI BIOS, they have iSCSI booting as an option. And so I'm curious. I'll have to see if anyone else has played with that. I haven't had a chance to sit down and kick the tires on it, but that was like, oh, that's kind of cool. I can maybe set up the compute on one TrueNAS and point it to boot from the storage on another. I'll have to give that a shot.
Exactly. I don't know that I'd want to use that as like a loop back for using it on the same box. It seems
no. Don't do that. That's inefficient.
That's inefficient. That's more complicated. Just to make sure everybody's clear. Like, if you're doing it on the same TrueNAS machine, you use the standard pass-through, use that local volume, and the loopback device they already have in place. It's going to be way more efficient. But this does open up some interesting ideas for us of being able to say, let's host the compute on one TrueNAS machine over here and have it iSCSI boot from a different TrueNAS machine. That's going to be interesting. I want to see people poke that one around, see what kind of crazy ideas you can come up with.
If you're wondering where I found this, it is kind of hidden. So when you boot your VM and you bring up VNC or whatever, you have to let it go through its boot options, and eventually it'll drop to a UEFI shell. Just type in exit, and then it'll dump you into the BIOS, which says, oh, you can add an iSCSI initiator to boot from. It's like, oh, cool. So like I said, one of those little, I don't know if it's documented, undocumented. It's just something I hadn't noticed before. Again, I kind of stumbled in it inadvertently last week. So we'll have to give that a shot, see what it looks like.
We'll go combing around in the Incus documentation, see if we can find out anything. If there is, I'll drop it in the comments below and the links below in the descriptions, as I always do. So
sounds good.
Yeah.
Okay, so we also have a little PSA related to what's going on here with Fangtooth. So related to apps, though, if you're still on Dragonfish, consider this one of your warnings. We basically have an upgrade planned, scheduled for June 1st, which is going to make upgrading from Dragonfish to either Electric Eel or Fangtooth impossible beyond that date. The migrations are no longer going to work. So if you do plan on upgrading from Kubernetes to the Docker apps, please do that in the next few months. You only have a few months left. Your window is limited. So this is important. Why? June 1st is when we expect to merge the apps support for being able to use IP-based forwarding with Docker, which is great. Lots of people are asking for that. We need to get that in. Unfortunately, it breaks the migrations coming from the old Kubernetes system. So again, consider this your warning. Please get on those upgrades. Again, Electric Eel .2 is out at this point. That is by far and away the most used version of any software we have of TrueNAS. So it's pretty darn stable at this point. You really should try and schedule some time to make that upgrade happen.
Yeah, that one's ready for general use for pretty much everybody out there. 2410.2 has been great. The whole 2410 tree has been great. I've been using it since it came out, and I think it's been an overall fantastic journey. So just especially if you're still on that version of Dragonfish, which would be 2404, you're coming up on about a year old. You're getting close to soon you'll be 2 major versions behind. It's probably time to consider, even if you don't want to jump straight to Fangtooth when it comes out, take a look at 24.10.
Absolutely.
Get in there, let it do its automatic upgrading and migrating of the apps, and then you'll be on the Docker infrastructure, and you'll have a much easier time making that transition again when we enable the IP-based port forwarding.
General rule of thumb is you don't want to get more than a version behind. So again, even in the most conservative of use cases, if the next major version is out and it's already at a .2 or a .3 and it's well beyond, the initial rollout period, it's time to consider it.
Yeah, have a look at that TrueNAS software status page and take a look at, the sort of user profiles, see which one you line up with. Even if you're a very risk-averse user, you're probably going to find that it's time for you to jump in on that, 24.10 train now.
Actually, we have some interesting things happening with Goldeye with those user profiles and upgrade paths and all that. So maybe I'll tease it now. We'll talk about that in a future episode, but that's going to be very interesting. I think a lot of people are going to like what we got going on there.
I think they'll enjoy that one too. I've been looking forward to that as well. So
okay, well let's get to our topic this week. One of the things we kind of skirted around in last week's episode where we interviewed Captain Stux, which was the whole LXC thing. But this is kind of a good topic that made me want to circle back and say, could we educate new users and talk about the differences between, say, apps and instances, or if you want to talk technology, Docker versus LXC versus KVM. Specifically, we want to provide some guidance on where each technology fits best into whatever potential use case you might have. Now, again, this might be repetitive for some folks. Yeah, I'm a Docker expert. I'm an LXC expert. Okay, great. Fine. We have a ton of new users joining TrueNAS all the time, though, who don't understand the subtle differences and nuances and may end up picking the wrong thing just because they don't quite grok the differences yet. So we're going to try and see if we can demystify this, hopefully use this as reference down the road.
Absolutely. There's a saying that says, somebody discovers something new. There's 10,000 people who do that every time a day. I'd love to say there's 10,000 people discovering TrueNAS every day, but there's definitely a good chunk of them that are coming on board. This is their first experience. So we want to make this good reference material so that you can understand where you're going to want to use each of these different sort of virtualization and containerization technologies.
Absolutely. So we'll start with the big one, of course, Docker. Docker is the backend for our app system inside of TrueNAS. So if you go to the apps page, everything there is being deployed and managed and run through Docker. That's kind of the granddaddy. So what makes that special? Those are best for apps that you don't want to fiddle with too much, especially on upgrade. They're very similar. You could call them cousins to LXC in the sense that they are lightweight containers in the end. But what's different is that the OS images, the base images of those are pretty ephemeral. You throw them away. They don't matter. What really matters and the persistence you get from those applications comes from this idea of Docker containers that you have usually a persistent volume attached, or sometimes there's more than one, but at least one. And that's where specific configuration, state data, all that good stuff lives on subsequent, redeploys of that app or upgrades of that app. So it's pretty common in Docker world. You'll see something where it's a container spun up and often they'll mount a persistent volume to the /data location inside the container. That's important. There's the host view, which is everything you see on the TrueNAS side. But within the container, it can only see the things you tell it to see. And 9 times out of 10, you'll have a /data mounted inside that Docker container. Maybe some additional directories, /configs pretty common. Image might have /upload, /videos. Wherever they plan on stashing those persistent files, those are the mount points that are going to be exposed.
Exactly. It's having sort of those, they're not hard requirements that Docker apps use those, but it's sort of the de facto. So everybody says, hey, if I'm writing something for Docker, I'm going to point it to /data. I'm going to put my config in /config. If I have some sort of temporary cache that might benefit from being able to broke out to a different location, I'll put in /cache. And then what you can do as a TrueNAS user, you say, well, I'm going to put my configuration. Maybe that's really tiny, but it needs to be fast. I'm going to put it on solid state drive. You can, adjust if there's your larger data store. If you say this is where the bulk of the writes happen, and maybe they're just slow writes. It's a download application. It's not necessarily a database, but it's something else. You say I'm going to put that on a hard drive based pool because the speed isn't so critical. I want much more capacity. Mm-hmm. And then you say, hey, that cache file, I'm going to use a tempfs, a memory backed volume, something like that, to just say this is just cache. It just needs to be fast. The app's using it for something internal, and it can be entirely throwaway. They're going to say, we're going to write this to this temporary file system. Mm-hmm. So
and this is kind of the beauty of it. And this did take me a little while to wrap my head around back in the day when I first started looking at Docker. I came from FreeBSD world. It was all jails and everything was persistent and all that good stuff. But Docker's like, oh, it's weird. Only certain things are persistent. It's like, yes, I learned to embrace that and love that because it meant my upgrade window was so much smaller and easier. Once you kind of get things just defined and deployed in Docker, it's a very controlled and rigid system, intentionally so, because it makes it super easy to manage and migrate and update later. Again, this is why I've said multiple times, and I'll keep saying, my upgrades for Plex back in the day used to go from, okay, I'm going to be down for a good chunk of Saturday while I go and upgrade the jail and figure out the packages. And, oh, I have this other library and I got build that from ports, blah, blah, blah. All that went away. Once I kind of just made the jump, I just click a button now. And then it spins for about 10 seconds and then it's done. And I'm like, okay, well, that was boring. I guess on to something else. Yeah, which is good. I want boring for upgrades. So.
Exactly. But boring and, intuitive for an upgrade for most things like that is fantastic. But if you are one of those people who either, like Chris, enjoys sort of that process of, turning the knobs, customizing, or it's a necessity in order to do it, then this is where the next level of LXC and the containerization in Incus comes in. So,
Absolutely.
Of course, yeah, it's a much more flexible environment. It's closer to a full VM. However, what you're not virtualizing is the kernel itself. So the core running piece of that, operating system. So
absolutely. But otherwise, for most intents and purposes, it mimics a full VM. For example, you're not limited to just a small application. You can say, I want an entire Arch Linux distribution, if you will, running in LXC. And when you log in, you can set it up with its own IP. You can SSH into it just like it's a VM running in your traditional virtualization. The biggest difference between, say, this and your Docker is that persistence. And we'll talk about native access to storage as well. But one of the cool things about LXC, and then we'll get into how this compares to, say, a full virtual VM, with QEMU, KVM, all that good stuff, is it gives you native speed access to your storage. This is a big deal for a lot of applications. For example, a mount from your host into the container is just like in Docker. It's fast. There's no middleman. You're basically cutting out having to go through SMB or NFS, all that good stuff, which gives you as close to bare metal speed as you're ever going to get in any kind of virtualized environment. Again, same as Docker. Docker also has that advantage. But on the persistence side, what's super important is, again, if you're coming from FreeBSD world and jails, you kind of already get this. It basically means it's just a full OS in a box. You can go make random changes to files in Etsy, or you can use the internal package manager. You can muck with systemd and change boot things, which normally you don't have access to those in Docker because those are blown away upon update, right? But it gives you that full flexibility and customization if you're a little bit more of a traditional Linux system administrator. If you say, yeah, I know how to use sudo and I'm comfortable having root and, I'm old enough to have the car keys, fine. That's a good option for you. It gives you that ultimate flexibility in the customization of your workload. Yeah. So a good example is deploying different services where you need a really custom recipe and there's not a good Docker equivalent or package for you. Custom database, Nginx, base system modifications, etc.
Yeah, or especially in terms of the package management, maybe you have a package in there it's already in the base version of TrueNAS, and you don't want to change it because you say, hey, this might break something on my base system. You can make yourself a little LXC. You can have it be almost a sandbox in that sense and say, I'm going to upgrade the package inside the sandbox. I'm going to use this different version of it inside the sandbox. Nothing's going to get touched on the host TrueNAS system. It's going to continue to run with its own version of it. And your, LXC container can run with its own version. Everybody's happy in there.
Which means, of course, when you do your TrueNAS upgrades, things persist as well. This is why we try and warn people against making base system changes, because again, we don't know what changes you're making and they are going to get blown away on upgrade. This is your persistence way of saying, yeah, I do have my special hardware tools or something because I need to do something for my drives or my HBA tools, whatever. Yeah. Like you can put them in that sandbox and they can live there forever and keep on upgrading and life goes on.
Yeah, a lot of people are using, they were using Jailmaker before, I know, and I think a couple of people have transitioned to LXC. They're doing things like fan control for specific pieces of hardware that can't be done with the native tools that are in TrueNAS. Somebody even said they set up an RGB controller, and they have all of their lights turn red when they have a drive failure. So they said they just kind of walk by and they'll see the glow from their basement to say, if there's red, it means I need to go check out and log into my TrueNAS server and see what's going on. I mean, that's a creative way to do it, certainly. But
that's a very cool customization. I need videos and pictures. That's kind of slick.
Yeah, if you happen to be listening to this and you've done something crazy with like your RGB notifications, or you've tied it into like a home assistant, if you're doing something wild in a container, like let us know. We want to be able to see that. We want to put screenshots and share what you're doing on the show with everybody who's watching us on YouTube.
So getting back to the pros and cons of LXC, so let's jump over to the con side. It's the same as the pro in many ways because it is fully configurable and customizable. It means everything's on you. Upgrades are on you. You're running Debian in an LXC. Well, guess what? You're going to do updates with apt, or if you're using Arch, you got to go update in the Arch mechanisms. If something breaks as a result of those upgrades, well, again, that's on you. It's just like having a VM in that sense. So with all that power comes responsibility. It's easy to foot shoot and mess up your container if you don't know what you're doing. Unlike Docker, which has a little bit more of that set and forget. It has all the handrails and tends to be all stable once you get it dialed in. So again, it's just really a personal preference, or sometimes there's certain apps that just require this kind of functionality so you can really get the fine-tuned nitty-gritty configuration dialed in.
Yeah, and despite saying, there is the risk of breaking something, at best, you can sort of break it inside the sandbox, and because you're in there, you're hopefully not going to be breaking your host TrueNAS operating system. The worst thing that's going to happen is you'll say, well, I'm going to have to toss that sandbox out, and I'm going to have to start again.
Absolutely. So now we get to the full granddaddy of virtualization, KVM and QEMU back. This is your traditional virtualization environment. This is what you'd normally use anytime you're setting up any kind of non-Linux thing running on TrueNAS. So Windows, for example, maybe you're running a BSD or something. Cool. Or you happen to need a custom kernel for some Linux distro of choice. The only one that annoys me is I run Home Assistant OS in a VM.
Yeah.
I really want to move that to LXC. And I know it's not technically supported, or they say it's for very scary advanced users. Man, somebody needs to build an actual LXC like container that ready to go, just because it's a little bit of a pain to set up. And I haven't been able to dedicate enough time to do it yet. But
it is. I would say like a lot of people do run Home Assistant on TrueNAS. And one of the challenges we have is a lot of people say they want to run that VM. And I find myself every so often I'm having to, rewrite that command of here's how you port that pre-made Home Assistant VMDK or their flat file image, load this into TrueNAS. So I'll have to make sure that I update that, have those lines ready for Fangtooth when that, when RC1 comes out. So I imagine we'll see a few people doing those new deploys, doing those migrations where they say, hey, how do I get a fresh copy of the HAOS VM fed into our LXC instances page now as a virtual machine? So yeah, we'll make sure that's
before anybody's a bit of a smartass and objects and says, Chris, why don't you just run the Docker version of Home Assistant? There are reasons not to. I would love to, believe me, if it all worked and did everything I wanted. The biggest thing is it doesn't support plugins.
Yeah.
So in my Home Assistant setup, I have a projector. It needs a Telnet plugin so I can go and do fancy control codes and stuff and get it to do what I want on the network. So that rules out the Docker instance. That's really a Home Assistant thing. It's just the way it's architected, unfortunate. But again, Home Assistant folks, if anybody hears my voice, please get us an LXC image just kind of ready to go and default. That would be awesome. That would make life so much
help
easier.
You test that out there.
Absolutely. Sure. Absolutely. Because I would love not to run it full virtualized.
Yeah. We now return you to our regularly scheduled virtualization content after that wonderful little rant.
Sorry, I needed to have a little rant there and get some things off my chest.
That's all right. So I mean, again, one of the benefits of that is you can, or I guess the benefits and the downside is being able to sort of reserve and lock in the resources when we're talking about CPU, memory, or even things like those PCIe devices can be fully reserved and passed through to a virtual machine. But of course, that means if they are reserved in this case, it's much more difficult and in some cases impossible to share them with whether it's your host OS or your other containers. It does mean there's also heavier overhead for a virtual machine. You are truly emulating that hardware on your own hardware with that software shim layer in the middle. So it's not going to be the full level of performance when we're talking about, storage, memory, compute. You're doing a lot of duplicate work because you're duplicating the work that effectively your kernel has to do, your memory stack has to do, your network stack. And then crucially, you can't directly access a lot of that ZFS storage without the use of either that intermediary layer of you're going through a ZVol or you're going through a network protocol.
All those extra memory copies, not only on the host to get things into user space, into the network, and then also within the VM to get it out of the network and back into user space and into the kernel. It's just, again, not super performant. That's always my last choice, is using KVM if I absolutely have to. Sometimes there's no other option. It's great to have it, but when and where you can do Docker and LXC, those are going to be your two best bets, is my recommendation.
Yeah. If you do need the flexibility that a fully virtualized environment provides, then by all means you can do that. And certainly the performance overhead of a VM has dropped quite a lot over the past years. I remember it used to be something significant, and now it's generally barely even thought of, except in those edge cases where you're really trying to pursue things like low latency workloads, or you say, I just want to get the absolute fastest out of what I do have. For a lot of people, a VM does help. But again, much like with an LXC container, it becomes your operating system. It is on you to control your updates, whether you're doing that with, the apps or RPM or, Windows update.
Here we go.
Yeah. Select now. And I mean, when you're doing that, are you really the one controlling the updates, or has Windows decided it's time for your Windows 10 VM to try and upgrade itself to Windows 11?
Fun days.
Oh, joy.
Anyway, hopefully that was helpful for everybody, especially new users, and we've demystified a little bit of the three main options you have for running things on top of your TrueNAS. But we actually have a question that's somewhat related, so I'll dive right into this first one here, Chris. And I apologize, I didn't get the person's name, so my bad. Maybe it was on the email, I missed it. But hello, thanks for the podcast. I really like watching it every week, and more big projects to do something similar. Well, thank you. We appreciate that. Here's the question. Is there currently a way implemented or planned to back up Incus disks? I tried creating a snapshot task for the entire pool where Incus is configured to store data, and it seems not to include the hidden Incus dataset. Same with the Cloud Sync task I created. I think the ability to back up VMs and containers is an important function, especially for our NAS, where not losing data is a priority. You would be correct. That is very important, and it's something we're actually working on internally here. This is why the feature is still labeled as experimental. We still have things to do. Not only how to back up, but also do imports and exports. And we want to make sure we tie it into config backups as well, because there's some persistence things about Incus and those setups that we need to make sure are in the config file so you can download it, lose your boot device, re-import, and go back to town and be in good shape. So absolutely, it's on our list. It's something we're working on hard in the background. You'll see probably most of that fleshed out by Goldeye in the fall, I would expect. But in the meantime, please keep backing up your entire pool. That's the way to go.
Yeah, that question came from Flo, it looks like.
Oh, Flo. Okay, you found it. Thank you for finding that in the background.
Found that quickly on the side.
Appreciate it.
No problem.
Okay, you got the next one here. I think Jason sent us something again. He's becoming a regular. We're going to have to invite you on the show.
Exactly. You got lots of questions. I'm sure he would love to ask these in real time for us. So we got another question from Jason. He says, I loved episode 12 and the talk about compression. Thanks. He says, what is the process to change the compression level? I understand that just changing the dataset compression property only affects writes from then on. So how can I recompress an existing dataset? My initial thoughts were a replication task, because this obviously does the writes. I've experimented a little, and I'm wanting to preserve as much as possible. I'd like to use ZFS replication, not something file level like rsync, and discover that ticking when include dataset properties or full FS replication, compression follows the source. By setting a property override of compression equals zstandard3, it seems to have stuck, but almost no difference in compression level. That could be just that the new level can't do better, but there's a chance too that my process is flawed. Is this the right procedure? Thanks, from Jason. Well, Jason, you've definitely got it correct in that the process to change compression does require you rewriting the data. So in order to recompress an existing data set, you have to sort of copy it out and copy it back again. The challenge happens when you're using that ZFS native replication. You're not rewriting and recompressing the file. ZFS is just saying you want to take these records, these underlying ZFS already compressed records, send them from point A to point B, and don't change them at all. Like you're setting your property override of the compression on there is going to try and override it, for the data set itself. But the records themselves have that property to say, hey, I was compressed with LZ4. I was compressed with zstandard1. That way we know which algorithm.
Yes.
I've been in the M&E world. We know which compression algorithm we have to use to decompress it on the other side. So if you compress something with LZ4, we know we have to decompress it with LZ4. We can't just say, throw it on a zstandard data set and have it magically gain that property. So what you do have to put it through a file level sync, whether it's rsync or sync thing, something like that is actually going to read the whole uncompressed raw contents of the file, analyze it again with the new algorithm, and then pack it down to hopefully that newer, smaller size. That's the way you're going to have to do it. So that's where you'll want to use something that you ensure you're preserving all of those things, like your ACLs, your ownership, extended data attributes. What do they call that? The SMB ADS, alternate data streams.
Yeah, alternate data streams, yeah.
So, and SyncThing will indeed do that. So you could even set up a local to local SyncThing job between data sets, and that should handle that sort of asynchronously for you in the background, as well as if you continue to make changes, you won't have to rerun that sync. So that is one way to do that. Obviously, if you were on TrueNAS, Community Edition, if you're on the newer versions where we have all that support, I think it was it 2404 where we introduced the SMB ADS support. That's really
yes, I believe Dragonfish.
I believe Dragonfish was the one, and that's really the most crucial for like our Mac OS users who use those ADSs for things like their file coloring and the metadata tags are in there. But there's another little piece I just wanted to jump onto, specifically, Jason, because you mentioned that you have set compression to Z standard 3. Now, a lot of people know that the LZ4 algorithm has something that they call an early abort, which is basically if it detects that you're overrunning the specific compression buffer, it says, your data isn't compressible, I'm going to stop trying, and it'll just store it uncompressed. It won't bother wasting any CPU cycles. Something has been implemented in ZFS now that gives Z standard the equivalent of an early abort, because the algorithm itself doesn't have one. But LZ4 itself is so fast at compressing data. It was usually about, sometimes twice as fast as Z standard. It was fast enough to use that as an initial check to say, if we pass the first bits of this, data stream through LZ4 and it compresses, we'll take this as a sign that we could probably compress it even more strongly with something bigger. So it will then, I believe, if I remember my code correctly, goes through a quick pass of Z standard 1 as well, just to ensure that there isn't something specific to that would cause it to fault out and be incompressible as a result. And it will then apply the full level of compression at Z standard 3. Now, people might say, doesn't this have a lot of overhead on it? Again, LZ4 is so incredibly fast at compressing that there's basically
no cost.
There's almost no cost. It's essentially almost free. Usually, you're at several gigabytes a second of aggregate throughput on most systems doing LZ4. So, but you gain a significant improvement in compression ratio trying to lean into Z standard 3 and higher. You also get some interesting edge cases where something causes a false positive early abort on LZ4. Z standard doesn't get fooled by that, and you actually manage to reap the rewards. I think it was a lot of diagnostic imaging data sets that I saw where LZ4 would not compress them at all. It stored them uncompressed. Z standard took a look at the same data and said, yeah, I can pack these down by 20 to 25%. So it would then, save somebody 20 to 25% space on a very large pool they were using for diagnostic imaging. And that's definitely non-trivial. And from their perspective, they said the performance didn't change, and we just got 25% better space utilization. So that's something that's interesting. I will put a link to the pull request in the discussion in there for people who want to get right into the guts of it. But the short version is that anyone who sets Z standard 3 or a higher level of compression on their data is automatically benefiting from that. In TrueNAS, I believe it is 24.10 and above. I would have to go and check to see which exact version where we set those Z standard early aborts.
Excellent. Well, definitely play with it. And if you have a large data set, maybe do a sample first and before you go and move everything over. Make sure -3 is the best option for you, performance-wise versus compression-wise and space savings.
Absolutely, With things like compression, it's always best to do those test runs, see if you're getting the space efficiency that you want, see if you haven't impacted your performance. Most users, you'll find, until you're reaching above the 10 gigabit level, all of the compression algorithms, save for the really, intense, like if you're setting Z standard 9 or gzip 9 or something crazy like that, well, you're going to feel it. You'll probably be bottlenecked by your compression algorithm, even on gigabit. So do your tests, make sure that it's going to have the proper impact that you want as far as gaining you some space without having the negative impact of losing you a lot of performance.
Absolutely. Well, excellent. Well, again, thanks, Jason. Keep the questions coming. We love it.
Yeah, absolutely. Yeah, thanks again. I mean, that wraps up our episode for today, Chris. That was a lot of good information, sort of on a base level for virtualization. We hope that our new users enjoy that, and we hope that our more technical ones enjoy when we get to geek out about some of that stuff like compression. I really do enjoy it. I'm sure everybody can tell that. So again, we enjoy those questions. Again, please keep them coming to t3@truenas.com. You can also drop your questions in the comment section below. Please don't forget to like the video, subscribe to our channel so you don't miss the next episode. and we will see you next time.